Hello, my name is Victor Ramos, and I will be teaching you today about rational functions. Now, everyone asks me what is rational functions? It's pretty much more so like a ratio or a fraction of a polynomial equation. Trying to figure out like fractions, but algebraically. Now, a perfect like one equation I could think of that would help illustrate this would be to start off, let's do something simple, something not too complicated, doesn't involve any exponents, but something like 2. Oh, something simple like 2 over x minus 1 equals 3x plus 2. Now, the two main cases of a rational function is simplifying the functions, and stating restrictions upon the functions. Now, one golden rule of a rational function is the division by zero error. In coding, that means you cannot divide by zero or else you would get this error. But in the world of pre-calculus, that means that the denominators can never equal zero. See that? None of the denominators can equal zero. So automatically, you have to state restrictions that can never make any of these equations equal zero. So automatically, this equation cannot be positive 1 because 1 minus 1 equals 0, thus making this undefined. Remember that, because in some questions, you'll get an option as if an equation is undefined. Now, continuing onward and forward, in terms of complex ones that involve polynomial, we will do factorization, but we will do that in a later equation. For this one, we'll have to do something called cross multiplying. That is when we cross the denominator of one equation with the numerator of the other equation, and the same thing goes on with the other way. So in a way, it's cross multiplying. So to display this in an easier way, let's do it this way. So we got 3 times x minus 1 3 times x minus 1 and 2x plus 2. And so remember, x cannot equal positive 1 or negative 2, as it will create a division by zero error. So when we multiply this all together, it will equal 3x minus 3 equals 2x plus 4. So what we do next is subtract 2x from both sides so that then, oh, I apologize, I got these crossed up, but 2 is supposed to be here and 3 is supposed to be here, just to give it for relevance. It's the same thing. But I like to do it in order based on how the original equation went, whereas the 2 was here and the 3 was here. So with this, let's remove 2x from both sides so that x is isolated only towards one side. So you're left, once you remove 2x from both sides, you have just x minus 3 and then just a 4 because the 2 is already gone. And so 4 equals x minus 3. And so what we would do here is add 3 to both sides, and we're left with x equals 7. Now, let's plug it in to our original equation, which I have written down on my notes, so I don't lose it, because I have a terrible memory. So the original equation is 2 over x minus 1 equals, so 3x plus 2. So now if we plug 7 into this, 7 plus 2 equals 9, and 7 minus 1 equals 6. So that means that there is no division by zero error, and we're left with 2 over 6 equals, sorry, I'm a little slow today, equals 3 over 8, which is correct. And so that is a one equation that doesn't involve factorization. But now we're going to talk about factorization that also involves simplifying the equation by using factorization, and then we do elimination of process. Well, let's go into the second equation, which I also have in my notes. And so the second equation is x squared minus 9 over x plus 3 equals 5. Now with this, you have to be able to factor this so that you'll be able to eliminate the polynomial on the other side without having a division by zero error. So, what equation do you think can work this that can also somewhat eliminate the x plus 3? What I'm thinking of is maybe x, you need two x's because it's an x squared given, and so you need a plus and minus because it ends with a negative. And what I could think of is 3 plus 3, because if you put 3x plus 3 minus 3x, that equals 0. But if you do positive 3 times negative 3, put the brackets here so you know it's a times, then you have that. Uh-oh! We have x plus 3 equal to the denominator. So that means that we should eliminate. Now, I know what you're wondering. Doesn't that mean that if this is eliminated, it will equal 0? But that is incorrect, because every equation that has a variable in it is automatically going to weigh this. It's 1x plus 3. The 3 gets eliminated, but the 1 is still there. Thus, only leaving behind the x minus 3, because x minus 3 over 1, any numerator over the denominator 1 is its own value. So it's x minus 3 equal 5. That's what we're left with due to the process of elimination. And we got to state the restriction. So automatically, x cannot equal negative 3 based upon the denominator, as it will give it a 0. So what number minus 3 could equal 5? Well, in basic algebra, the answer will be 8. So x equals 8. And this is given a rational function equation with the use of exponents. My name is Victor Ramos. I hope this has been useful. Have a wonderful day and a happy summer.